This is a lesson on SOH CAH TOA, primarily dealing with tangent, on finding the missing parts of a triangle. So SOH CAH TOA is a core lesson you're going to need. Using the hourglass rule, we can keep our changing of narrow things and changing of easing values constant in regards to SOH CAH TOA. Breaking down what's opposite, adjacent, and hypotenuse. In the other videos I went over this before. Everything is in perspective of a point on an angle of the triangle. What's adjacent to it? Adjacent to an angle is a side that's touching it, which is not the hypotenuse. The hypotenuse is always the side opposite of the 90-degree angle. SOH CAH TOA only works with when you have a right triangle. Therefore, we will always have a 90-degree angle. Opposite is exactly as it sounds like. It is opposite of the focused angle. SOH CAH TOA may be hard for some people to remember, so some people use some old hippie called another hippie tripping on acid. We're dealing with tangent for today, so we can say tangent of theta is equal to opposite divided by adjacent. So theta is just a fancy variable for an angle, and we can say that tangent of theta is equal to sine theta divided by cosine theta. So tangent of theta logic. Tangent of theta is always opposite over adjacent. Let's just say we know we have one angle and one side, or one leg. We don't need a hypotenuse because tangent doesn't deal with hypotenuses. We can say that 42 tangent, we get this value right here. And we know that tangent is equal to opposite over adjacent. We have the opposite side of this angle, but we don't have the adjacent. So we have to do a little bit of algebra. So we can say that tangent of 42, which is this value, is equal to opposite over adjacent. But we need to know our opposites, but we need to know our adjacent side since we know our opposite side is 7. We need to get our unknown by itself. So what we can do is multiply both sides by the adjacent value. So adjacent times 0.900 and so on is equal to 7. So what we could do is we have this new equation. Adjacent side times 0.900 is equal to 7. We can divide both sides by 0.900, which is the value of tangent of 42. While we could write all this out again, it's time consuming. So what I like to do is I put this in storage 1, and then I can say 7 divided by recall 1, so I don't have to write it out again. And it will give us our adjacent side of 7.77 and so on. But how do we know we're right though? Well, we can put it in the inverse function, our arctangent. With an arctangent, we can say opposite, or arctangent of opposite divided by adjacent should be equal to our theta. So we can say arctangent of 7 divided by 7.77 and so on should be equal to 42 degrees. In order to get to your arctangent, all you have to do is press that second green button in the top left corner and press tangent. So let's do this one together. I know I'm going to use that 7.77 value. So I can put that into storage 1. I could put it in storage 2 or storage 3. It doesn't matter as long as we have it in our calculator's memory to save us time. We clear this out. 7 divided by our recall 1 We get our 0.900, the number should look familiar to you all. And then we just press second, tangent, and it will shoot out 42 degrees. Which is the same number we had on the previous slide, proving we are right. The question is, why do we even want to know this? Well, if we know our changing of northings and our changing of eastings, it will help us find bearings. So, if we're going from point A to point B, if we know our north-south line has a changing of northings of 3 and our east-west line has a changing value of 7, we can find the interior angle right here by saying our opposite divided by our adjacent. But because we are just trying to find an angle or trying to find a bearing, we're going to use our arctangent value. So we can say 7 divided by 3, we get our equal sign, second tangent, so to get our arctangent value. This 66.80, that's decimal degrees, we want this in DMS, so we press second, the equal sign, and we'll get 66 degrees, 48 minutes and 5 seconds. Because we traveled south then east, we can slap some coordinate directions into them, saying it's going south and east. This is a quick flow map I made, determining on what you want to use. So when I say a leg right here, that just means a side that's not the hypotenuse. A leg is a very common term in the use of right triangles. So you ask yourself, do you have an angle that's and one leg? Keep in mind, no one cares about that 90-degree angle. We want one of the other two. Personally, I like using the bearing line. So you ask yourself, do you have an angle in the leg? Yes or no? Let's just say if you said yes, just use tangent, because we have a angle and a leg. Tangent's perfect, you just have to determine if you have your opposite or you have your adjacent and which one goes on to the numerator. It's always opposite divided by adjacent, you just got to know what one you have. Let's just say, do you have an angle and one leg? You could say no. So you have to ask yourself, do you have two sides not including the hypotenuse? If you say yes to that, you're going to use arctangent. If you say no to, do you have two sides not including the hypotenuse, and you already said no to having an angle in one leg, well, you may have the hypotenuse, and that means you should try sine and cosine. You shouldn't use tangent for that case. Thank you very much. Let's see what we can go on from here. Oh, that's it.